So this was a last week pop quiz related to topic light and the waves. Figure 5.1 shows a road junction, means intersection of the road, a moving car and a stationary truck. The road has a high wall on each side. The driver of a truck is at position X, as you can see here. The car moves round the corner on a figure. Label a point Y on the road where the truck driver first sees the car. Where the truck driver will see the car first, which position he will see. Because driver, yeah, the driver is here, so means even if let's take a real life example. If you are a truck driver, you can this is the site which you can see. So what is the position he can see? We have to label the driver of the truck is at position X. The car moves on the corner. On label a Y, where the truck driver first sees the car. So he can see the car here at this place, anywhere you can draw. Okay, because this will be blocked. Light cannot pass through the wall. So how to identify or recognize this position? What you simply have to do, you have to just draw a line and the position on anywhere on this line you can position Y. Like this can be Y, this could be Y, this could be Y, anywhere this could be Y. This is pop quiz 8, the last week pop quiz. Now a mirror is placed at the road junction as shown in figure 5.2. Show how this mirror allow the driver of the truck to see the car when it is at the position shown. So how a driver is able to see this, a truck driver is able to see the car. So it's you just have to show a reflection, like a reflected ray should be there. So yeah, you can start from here, but just you have to show a reflection. Okay. You can draw a ray from here and strike, but the angle of incidence should look like same as the angle of reflection. So that's how it could be seen by the reflection of the light. For the first point, they ask, what is the position a truck driver will see the car? Because this is a wall here, so the viewpoint of a truck driver this is a viewpoint. Like only anything within this viewpoint he can able to see. So the question is mark with the letter Y where the truck driver first sees the car. So if a car approaches here, he can see the car in this region. That's because the car is moving, and this is the position where he can, because that's the viewpoint. Only this region he can cover. Why he cannot cover the other region? Because it will be blocked by the walls. In part C, the truck driver wears spectacles to correct the long-sightedness. Long-sightedness means we are able to see the objects which are far, but not the objects which are closer. Like because the light rays are not able to converge on the retina. Okay. Yeah, so it can be long-sightedness or short-sightedness. Long-sightedness, far objects can be seen, but not the close object. Figure 5.1 shows a blurred image of an object forms on a retina. Why a blurred image is formed on the retina? Because any effect of a cornea of the ray of light is being ignored. Figure 5.4 shows how long-sightedness can be corrected. Add a suitable lens in front of the eye. So we have to do it for figure 5.4. And then continue. Then we have to continue the path of the three rays until they meet to form an image. So the next figure. This is pop quiz 8. Pop quiz 8. Yeah, first one. So which lens we use? We use a convex lens, converging lens for the long-sightedness. So we draw a convex lens or a converging lens. This is perquisite. Okay, here, boys. We have a converging lens.
Yes. Now let's start.
What is the advantage of using a converging lens? Converging lens will convert the light rays. So these light rays, when it passes through a converging lens, it will convert the light rays on the lens, and then the lens of an eye converge on the retina. That's how the figure should be drawn. So you have here which lens you have to draw. You have to draw a converging lens. So for a long-sightedness, use a converging lens. For a short-sightedness, you will use a diverging lens. What? Convex. This is convex. Concave. So defect of an eye, whenever you see a question related to defect of an eye, there are two defects of the eye. What is the one possibility that the light rays, this is a lens of an eye, and the light rays may not converge on the focus. That is one possibility. Okay. And the second possibility, the light rays may not converge on the retina, means after retina. So both cases, the image will be blurred. This will produce a blur image. This will also produce a blur image. So for correction of the defect of an eye, we use a lens. We use a convex and a concave lens. So here you can see in a long-sightedness. Long-sightedness means we are able to see the objects which are far, but not the objects which are closer. And short-sightedness, we are able to see the objects which are close, but not the objects which are far.
Why is there so less bending on the concave lens?
If you are using a thick lens, then it will have a greater bending. If it's a thin lens, then it will have a smaller bending.
Greater bending?
You can draw a greater bending. You just have to show the the refraction of the light, that the light is being refracted.
Okay. Like at the it should be at the focal.
No, that's not the correct.
Focal point कैसे सही होगा तो मैं वहां भी पहुंचा जैसा करतो के लिए बताना है कैसे हम इस्तेमाल करेंगे हेलमेट लगा के बना रहे हैं मुझे ये ग्लासेस है ना हाँ लेंस वो ही ग्लास है वो ही
Here, these are the defect of an eye. Okay, we have the short-sightedness. The short-sightedness, like the normal vision. Boys, don't talk. We have a normal vision. In a normal vision, the light rays converge on the retina. We may have a short-sightedness. Short-sightedness means the light is focused before retina. And it means the distant object, the objects which are far, are we are not able to see them clearly. And we have long-sightedness. Long-sightedness means the light is focused after retina. So the close objects, the objects which are close, appear to be blurred. And how we can overcome this defect? That's how you should draw. By using the lenses. But you can use a convex lens or you can use a concave lens as well. Okay?
The lens is harmful for our eyes. It can be direct in our eyes.
What?
We should use glasses.
Sir, this one for short or long? This one.
Convex. This is a convex lens. In a long-sightedness, this is a long-sightedness. Okay? Long-sightedness means the light rays converge after retina.
So
for a long-sightedness, this is long-sightedness, for what we use for a long-sightedness, we use a convex lens. So that's how you have to draw that lens. And if it is a short-sightedness, you will use a concave lens. This is a diverging lens or a concave lens. Okay. So if you see the figure in the question, they mention which sightedness is this? Long or short? No, this is not normal. If it was a long, it's already mentioned. So if it's a long-sightedness, the light rays are not converging. Which lens we should use? We should use a concave lens. So that is what you have to do. You have to use a concave lens in the next figure, and you have to show the light rays converge. So here, even you can draw the lens here at this position. The light rays passes through the lens. The light rays will converge, not completely bend, and then the light rays passing through the lens will focus on the retina. Okay. Is it clear? So defect of an eye, you have to practice these drawings. And it's a converging lens or a convex lens is used for a long-sighted.
Draw a line to represent the lens.
No, for a lens diagram, the image formed by a convex lens, you can use line there, but not here. Here you have to draw lens because you have to show which lens is used. The next is figure 7.1 shows some electromagnetic radiation. Electromagnetic radiation means the radiation which can travel through vacuum. A Bluetooth handset uses a radio wave. Thermal imaging, what it use?
Infrared.
Photography of people's face.
Infrared. Photography of the, so we need a visible light to see the people. Sterilizing the medical equipment. Gamma rays.
Also ultraviolet.
UV, yes, UV can be used, but there's no option of a UV. That's why we selected a gamma. State the speed of electromagnetic radiation in a vacuum. So it is approximate. So all these electromagnetic waves travel at 3 into 10 to power 8 meters per second. Okay. A Bluetooth headset can be used to listen to music on a mobile or a cell phone without need of a wire to be connected to the handset. The headset uses frequency range from 2.4 to 2.48 gigahertz. Calculate the wavelength of a radio wave when the frequency is in the middle of the frequency range. So first, what is the middle of this average? What is the average? 2.4 and 2.44. So 2.44, but giga means what? 10 power what? Giga. We have kilo, we have mega, we have giga. 10 to the power 9. Gigabytes. Yeah, it's the same thing. Giga is a. It's like 10 power 9 bytes. Terabyte means 10 power 12. Same prefixes. Petabyte, 10 power 15. Etabyte, yetabyte. So calculate the wavelength of a radio wave. So we use the formula speed is frequency times the wavelength. The speed of these electromagnetic radiation is 3 into 10 to the power 8. The frequency is 2.44 exponent 9. And the wavelength is unknown. We need the wavelength, so this whole factor will be divided. So 3 into 10 to the power 8 divided by 2.44 exponent 9. What's the answer? 3 exponent 8 divided by 2.44 exponent 9. What's the answer? Tell your answer. So 0.12 and the unit will be meters. What? 3 exponent 8 divided by 2.44 exponent 9. The speed divided by the wavelength will get the speed divided by frequency will get the wavelength of this. The next is suggest why a Bluetooth headset only works well over a short distance.
gets weaker as it penetrates the walls.
Yeah, or absorbed by the material, or intensity reduces when it passes through a material.
कुछ भी नहीं सर ने कहा सर आपके आपने कैसे लाइनें यूज करी इसके चक्कर में मैंने सारे ब्रीफ आंसर दे रहे हैं
Good.
यार गुड डे में मैं कुछ भी लिख सकता हूँ वर्ड्स
But you are writing something related to physics. Huh? Yes. Yeah, right. I will share. Because it is absorbed by the which one? So it is absorbed by the when it passes through a material, it is absorbed by a material, or intensity of the radiation reduce when it propagate or passes or get weaker. Question 3. We have a planet position. Earth is there, Jupiter is there, and X.
Mars.
Venus.
I'm thinking that much.
Maybe Mars, maybe Venus.
State the name of this planet X. Look,
Venus.
the Earth, gravity of the Earth is 9.8. The Jupiter is 23.1. The gravity is approximately same as
So this is too near to the sun.
what?
This should be Venus. No, average distance from the sun.
This is the mass of that's the average distance. The average distance is closer. So what are the planets? We have Mercury, Venus, Earth. So it can be Mars or
Venus.
Mars or Venus तो correct है.
no, it cannot be Mars. Mercury, Venus, Earth, Mars.
Venus.
So
Venus.
yeah, because we have Mercury, Venus, Earth, then Mars is there. So it cannot be Mars. It could be Venus or Mercury. So actually it is, if you compare the distance approximately, so it's Venus is the right answer for this. Finish, don't, no discussion. Then describe a relation shown in the table 9 point Venus.
Venus.
Describe the relationship shown in the table 9.1 between the mass of the planet and the gravitational field strength. How you can relate the mass and the gravity?
As the mass increases, the gravitational field strength increases.
The relation between the mass and so the increase in mass increases the gravitational field strength of the planet, or planet with a higher or a greater mass having stronger gravity. Explain why the distance from a sun in the table is average value. Like why they did not, this said here it's an average distance from sun. Why not they said actual
Because
distance?
elliptical orbit, distance varies.
Yeah.
अरे आपने क्लास में बताया.
So we can say the orbit of the planet is not circular, it is elliptical, slightly squashed. What? Yeah, distance is changing, and why the distance is changing, you have to use the term that the orbit is elliptical. If it was a circular orbit, then we will not say, like the distance will not be, it will be same, like from all the points.
Yes.
The next is show that the average orbital speed of the Earth is approximately 30 kilometers per second, because we consider when we are calculating the speeds, the average speeds, we assume it is circular. So when we consider it is circular, so when object move in a circular path, speed is distance divided by time. So the distance move in a circular path is always 2 pi r. So 2 pi r divided by t. So it will be 2 multiplied by pi, which is 3.14, multiplied by radius. Radius is given because we need answer in kilometers. So we need the radius of, so it will be 149.2 into 10 power 6, because it's written 10 power 6 kilometer for all and divided by the time.
149.6.
The time is 365.2, the orbital period. That's the total time the Earth is taking to move around the sun. Yes.
149.6. No.
Okay, this
It's more-
365.2. Then the total time interval we have to convert into seconds. So we have 365 days. So we multiply by
34, then 60,
60 and then
then
60.
60.
so we multiply by 60 to convert into
60
hours.
Then
We'll multiply by 60 to
Then
convert into
seconds.
minutes. We multiply by 60 to convert into seconds. And what we'll get the final answer, it will be 29.9 kilometers per second. So Earth, or approximately 30 kilometers in 1 second, Earth cover.
29.77.
Okay, 7. It's the same thing, 29.77.
so how much is
3 marks, 1 mark is for writing. Look, what are the marks distribution? And 1 mark is for writing the formula. Speed is distance over time and using a distance 2 pi r. 1 mark is for converting the unit of the time correctly, and 1 mark is for the final answer.
I don't know.
So if I write the answer, I'll get 1 mark.
Yeah.
Sir, आपने weekly homework क्यों नहीं दिया?
I was busy, that's why I did not get to use it. Can you take that chair? Sit there, beside.
Boom. Then just do that. उसने भी नहीं सुना
Okay.
Oh my God.
Electricity.
I think something happened there. The socket. Can you check?
यहाँ पे भी जगह है
Sir, आप ये explain करिए कैसे हुआ?
This is what, sir?
No.
There are no questions.
Wait.
Sir, can you
The protostar. Complete the sentence about. Complete the sentences about the life cycle of the star. The protostars are formed from.
molecular clouds.
Protostars are formed from.
Molecular cloud.
Yeah, interstellar cloud.
What about molecular?
Yeah, you can say molecular cloud, or you can also say from hydrogen, helium, and dust. Yes. From hydrogen, helium, and a dust. It can form up. The protostars are formed. The next is a protostar become a stable star when
When the output and the input force are equal.
when the radiation pressure equals to gravitational force.
Sir, can you write nuclear energy?
Oh, no. When a radiation pressure which is outward balances with the gravitational force which is inward. When the outward pressure due to a radiation balances with the inward force due to a gravity, the star will be a main sequence star.
सर आप एक एक वर्ड लिख रहे हैं मैंने पूरा
Yeah,
Please open the door. एक दो word out particles can go out.
initial fuel used to power station reaction. Yeah, initial fuel
Hydrogen.
used
Hydrogen.
to power nuclear reaction in the star, that is hydrogen. State stars that are approximately same size as the sun become red giant, in which then red giants form a planetary nebula. And with a white dwarf at the center. So for a main sequence stars, when a low mass star is there, protostar turn into a main sequence, then red giant, planetary nebula, and the core will be a white dwarf. But if it's a high mass star, protostar, main sequence, then it will turn into a supergiant, then it will be a supernova, which result either in a formation of a pulsar, which is called a neutron star, or a black hole. Okay.
So wasn't there?
What?
There a black